Let me repeat again. You think of a number, anything between 0 and 20. Think of a number. You don't tell me what the number is. Okay?
Okay.
And
I got
then
it.
add 5.
Okay.
Then double it.
Okay.
What the answer you got?
48.
48. Right? So if I'm not to be wrong, you thought of 19. Is that right?
Yes.
So this is not a magic. This is not a magic. So what I have done is, really I don't know what you thought of. So that one I assumed as a variable. I'll explain what is a variable a little later. I don't know what you thought of, so just I assumed that one as x. And I ask you to add 5. And whatever the result you got, the whole result is to be multiplied by 2. Of course, I said that just double it. Double it means just multiplied by 2, right? And then
Yes.
what the answer you got means you answered that it is 48, right? So quickly I solved it. So how I solve this one, that I'll explain in my lesson. So here x plus 5 equals to 24, and how to solve this one I'll explain later. Okay, so x equals to 19. So this is what
they've taught me this.
Okay, this is called as a linear equation. So let's start with the basics. Let's start with the basics. Just give me
Yeah, they've taught me this stuff.
Let me give simple examples. So let's say that a number like I don't know what's the value of that, say x plus 5 equals to 7. Easily you can guess what's the value of x is, right? And say
Yes.
x plus 5. Is it okay for you to write what's the value of x here, please? That's good. So x plus 5 equals to, okay, will you please write the value of x here? The value of x here. That's awesome. Now you see that the value of 5 always stays the same. The value of 5 always stays the same. What is the value of 5? It is always 5, right?
Right, yes.
But when it comes to the value of x, it's the value of x, it changes. It depends upon the question. Right? So I'm getting different values. Once the value of x is 2, once it is 4, once it is 11. So it is changing from one question to the other question. In English, vary means different or change. I hope you know that. So from this term, we are taking it is a variable. Variable means the value changes. Okay, and here when I take the value of 5, it stays same every time. The value of 5 equals to 5. Even if you go to moon, what's the value of 5? It stays the same. It stays the same. That's the reason we call this one as a constant. Okay. Now let's go to some simple examples. So here the bottom line is the variables means the English alphabets, whatever we are taking while solving math problems, we call this as variable, and all the numbers I call this as constants. Anyhow, in order to avoid the confusion, at times I may use the terms like letters and numbers, which are the variables and constants. Okay. Now, let me start with a simple question. If I say that x plus 2 equals to say 7, easily you can guess that if I take 5 and add 2, then I get 7. So it's this is easily predictable. This is
Or
easily,
7 minus 2.
yeah, 7 minus 2. So this is easily predictable. But suppose if I'm giving, say, x plus 387 equals to 1711, these kind of numbers are given, it is not easy to predict.
Yes, then you use linear equations.
Yes, we use linear equations. At this point, what I'm doing is we are going to adopt the inverse operations. So inverse operations method we are going to. Just a moment, please. Okay. See, here I see that a variable is here. It is associated with a constant. Always our target is we have to isolate means we have to make it all alone. We have to isolate the variable. So how can I isolate this one? Means first of all I have to detach positive 2. I have to detach positive 2. So what is the inverse operation of inverse operation? Means what is the opposite sign? What is the opposite sign of positive sign? What is the opposite of positive sign?
Negative sign.
Negative sign. And we take the same value. Okay, not only one side, on both these sides we have to take it. You may get a doubt, why should I take on both these sides, why not on one side? Means the reason is so simple. I don't know whether you are aware of this one or not. Just I'm going to draw a simple balance. Actually, maybe about 10-20 years ago, people used to have this kind of balance. You may find this one in pictures. Like, let's say that if I put some 4 pounds of weight, what happens? This one goes down, right?
Yes.
Then, in order to balance, I have to keep the same weight on the other side so that I see that a horizontal one. Then this one will be balanced, right?
Yeah, in school we use something called a triple beam balance.
Mm-hmm.
This is almost the same thing. Like you put a weight on the other side, on one side, and then you try to equal the weight on the other side.
Okay, so here, thank you for bringing to my notice. Yes, you said right. And please notice that whatever the weight I put up on one pan, the same weight we have to keep. So you know that, like maybe in chemistry lab, suppose if you want to check the weight of some chemical, we put some 10 grams or 20 grams on one side, the other side we put the chemical so that we can check the weighment, right? So please notice that we have to balance it. So for that reason, here whatever the value I take on the left side, then if I take the same value on the right hand side, what happens is this is balanced. Now, positive to negative 2, integers, how to simplify positive to negative 2. They're opposite, they're opposite in nature. So when I combine, I end up with 0. So I'm not writing 0 here. I'm not writing 0, but I know that it's 0. So just I'm striking. That means that I'll end up with 0. Now 7 minus 2 equals to 5. Right?
Yes.
So I know how to figure out the value of x. That is by strictly adopting the inverse operation method in order to figure out what's the value of x is. Right? Now, if you take large numbers, exactly in the same way we follow the method, the inverse operation is subtraction. And we take the same number on the variable side. So it is take away 387, and at this point you may compute, positive 387, negative 387. These two are the same values, but opposite, with opposite signs. Like in the previous question, positive 2, negative 2, that gives us 0. Likewise, positive 387, negative 387, 0. So I'm not writing the value of 0 here, just I'm simply striking. Now, can you subtract or can you take away 387 from 1711? Can you do that,
Yes.
please? Go
Yes.
ahead.
387. Correct.
I appreciate you are checking that too. That's really awesome. Well, your answer 1324 is absolutely right, and I appreciate for checking back whether it is correct or not. Okay, now let's go to the next page, and this time the same kind of technique I'm going to use it to say that uh, 3 is subtracted from x and the result is let's say 7. It's a very simple question. Can you guess what's the value of x is? What's the value?
4.
Are you sure?
Oh, no. It's going to be 10.
That's right. So this is how there are chances of making a mistake. So probably you thought 7 minus 3, which is not right. Okay. And let's see whether is it correct or not. Simply you plug in back the value of x here and check it. Yes, 10 minus 3, that is equals to 7. And I asked whether it is correct or not if it is 4. So 4 minus 3 is not equals to 7. Anyhow, it is a simple question, so you could fix it by computing in your mind. But if I give you, say, x minus 800, maybe 79 equals to, say, 412, some number is given this way. So, again, you may subtract, you may end up with the wrong answer. How could you get the 10 means? Wait, hold on, please. Yeah, you are doing good. Just let's talk about the technique. So we go with the inverse operation whenever we solve these linear equations. Inverse operations. Our target is always to isolate. Always isolate the variable part. Okay, so let me isolate the variable. So how to do that, how to isolate this one means we have to go for the inverse operation. The inverse operation is I have to detach negative 3, therefore let me take the opposite sign, which is positive. I saw that you are writing the same, that is positive 879. So don't forget to balance the equation by taking a positive sign on both these sides with the same values. So negative 3, positive 3 gets cancelled. 7 plus 3 equals to 10. And I remember you were writing that to positive 879. Please go ahead and compute what's the value of x is. Mm-hmm. I like it. So you are double checking. That's good. Good. Very good. Good thinking. Is x 1298? Are you sure?
X
Mm-hmm.
equals.
Yes, that's right. That's right.
That's why I put x equals.
Yes. Okay. So let's go to the next page. I'm going to assign one simple question first. Say that 2 times x is some 16. Can you guess the value of x?
8.
Okay. Then how did you get? Can you explain the procedure, please?
So I did divide by 2.
Mm-hmm.
So I strike that. Then I put x equals, and then divide by 8 equals 2.
Okay. Now, one simple
No,
question.
no.
Okay. See, I know that you rectified your mistake, but always make sure that you are taking the same values on both the sides. You are taking the same values on both the sides. Then only your balance. You balance these. Agreed? Does it make sense? Okay. Right.
It
Now,
makes sense.
I'm going to give another question. Say that the product is 39,936. Then just a minute. Yes, 128 times x equals to this one. So how you are going to solve?
Cross.
You take immediately in order to avoid the mistake. I remember. So immediately you take on the other side the same value. Yes, yes. So you can avoid mistakes. Good. X equals to 300.
12.
That's right. Absolutely right answer. So now let's go to another model. This time I'm giving a simple question. Now think of a number. Think of a number that is divided by 3. That makes 7. Okay.
Any number?
No,
21. 21.
21, right? And of course, as I told you before, I want you to show your thought process, how you got 21. I agree with you. Your answer is absolutely correct.
Time. No.
Yeah, go ahead. Go ahead. Times?
Times 3.
Mm-hmm.
So just strike this. So x equals times 3.
Awesome. See, one small suggestion that when you write times 3, you write immediately on both these sides at once. Don't write them separately. Okay? So that you'll never make a mistake. Now let's go to another question, which is little, say, x divided by 14 equals to, say, 31. Now please solve this one on your own. I like it. So times 14. Okay. So 434.
34.
Right. And again, I hope you remember, I told you that do your calculation part, otherwise what is happening is it looks really little messy. Do you see that? So make a rough column and then do the calculations. Okay. So now let's go to a little advanced questions. Like say I'm going to give very simple question here. Say 2x plus 3 equals to 27. What is the value of x? Hold on. Give me a chance that I'll explain first. Okay. So I have to check. Our target is always to isolate the isolate the variable, I say that x. Now, which one I have to detach? So the question arises, do I have to eliminate 3 first or do I have to eliminate 2 first? If this is the question,
Eliminate
go
2
ahead.
first.
Which one? Is it 2 or 3?
Yes. 2.
2. But the rule is which is free from variable that is to be eliminated first. Which is free from variable that is to be cancelled first. I repeat,
Oh.
if it is uh, associated with the variable, please do not touch in the beginning. That's the condition. So, as you know, we go with inverse operations. Inverse operations. So,
Yes.
the inverse operation of positive, that is -3. Please don't forget, write immediately then and there in order to balance the equation.
So
So,
cross this.
okay, go ahead.
Wait that.
Mm-hmm.
So then I get x.
Is it x or 2x?
2x
Uh-huh.
equals 24.
Mm-hmm.
And then isolate this.
Okay, how? How to do that?
Divide by 2.
Mm-hmm.
Divide by 2.
Okay.
X equals 12.
Awesome. I have a question. I don't know whether your answer is correct or not. Then how you are going to check back?
I try 12x equals 24. So 12 times 2 equals 24.
Okay. What are you
12
said?
times 12 times 2 plus 3 equals 27.
So what are you said verbally? I would like to see in working, like say 2x plus 3 equals to 27. This is what the given question is.
Okay,
Now,
so
in the place of x, you plug in 12, just plug in 12, and then rest of the things, what are you said that is correct. So let me write the rest of the values as they are. Now 2 times 12, let me follow PEMDAS. PEMDAS, so multiplication first. I see that.
no, it's parentheses first.
Okay, so
PEMDAS.
but here we don't have parenthesis. I mean to say that parenthesis means here multiplication. So go ahead. You are doing good.
Okay, so 24 plus 3 equals 27.
Okay, so always you please check whether your left hand side values are they matching with your right hand side values or not. If they are matching, yes, your answer is absolutely correct.
They are matching.
They are matching, right? So let's
Yes.
try another question. Let's try another question. Say that 3x minus 3 equals to, again, 27. Go ahead. And I would like to hear what is going on in your brain. So please talk, think aloud.
So plus -3 plus +3. Straight that. So it's basically put a line right here. No. +3. So it's 30.
Mm-hmm.
So 3x equals 30.
Mm-hmm.
So x divided by 3 divided by 3. Strike this. So x so divide by 3. So x equals 10.
Absolutely right. Good job. Well, so I would like to take a little advanced. Let's say that You are given some 4x plus 7 equals to 9x minus, so let me take 23. Okay, so if you are asked to solve this one, this time I see that don't say that there are two different variables. Still, I see that the same letter, so same variables, right? So how to solve this one means, so step one, we have to see what is the variable on both the sides. Here 4x and 9x, right? And you have to look for the smallest value with the variable. Okay, which is the smallest of these two? Is it 9x or 4x? Which is the smallest one?
4x.
4x. So if no sign is there, just assume that there is an invisible positive sign. As you know that we go with the inverse operations whenever we solve while solving these linear equations. So the inverse of positive, that is negative 4x on both these sides. Make sure that you are writing x under x. So I repeat again, you have to look which is the smallest of the given two variables. Is it on the left side or the right side? That's what you have to see. I see that 4x is on the left hand side. You also confirmed. Thank you very much. And here I see that these two are having the opposite sign. So 4x, take away 4x. Obviously that one gets cancelled. 7 equals to, now 9x, take away 4x. What will you get?
5x.
5x. So 5x minus 23. Now here onwards, I'm sure you can continue working, but just if you want, I'll give you a heads up. I see that x is on the right hand side. This is to be isolated. So if this is to be isolated, what I have to do is, do I have to detach 5 first or negative 23, which is to be cancelled first? Is it 5 or negative 23?
The one that's not associated with the
variable.
The variable.
That's right. Awesome. Go ahead and continue. Complete this. Yes.
So positive 23. Strike this. So 7 equals 5x. So
did you balance the equation? That's what repeatedly I'm telling you. See, here, when you write a value on the left hand side, right hand side, you have to fill it immediately with the same value. Otherwise, there are high chances of making a mistake. Right? Okay. Is it 7 plus? Okay. Okay.
5x. So 5. Strike this. 5. So x equals 6.
Awesome. That's good. Then, do you know how to check whether your answer is correct or not? Your solution part. Is that right? How to check? So this question I'll help you. Please give me a second. Yeah, you are right, but still let me give you an idea how to check it. Okay, so just give me a second. So you please copy the entire question that's given, that 4x plus 7 equals to 9x minus 23, right? And what are the value of x you got, you plug in back this one here as well as here. Okay, and I know that x value is 6. In the place of x, I'm supposed to take 6 there. Then it is 4 times 6 plus 7, 9 times 6, take away 23. So let's follow PEMDAS. So first the multiplication is to be carried. So 4 times 6, that gives me 24 plus 7. So go for simple addition, 31. And the other side, 9 times 6, 54. Let me take away 23. So 4 minus 3, that gives me 1. 5 minus 2, that gives me 31. So I see that here, left hand side, whatever the value I got, on the right hand side also, I got the same value. That shows that whatever the value of x I got, that is correct. So my value of this variable is absolutely fine. Okay?
Yes.
Now, let's go to another question, and this time I'm taking, say that, let me give a different alphabet instead of x every time, say 7p minus 24 equals to maybe 15, 15p plus. So let me take 15p minus 88. Yeah, you start working now. I would like to hear what is going on in your mind, so please think aloud.
So which one is lower? So it's this one. So I do positive 23 to divide by 7. Divide by 7.
Carefully. So, step 1 is identify the smallest variable of the two. So, identify the smallest variable of the given two. I see that one is 15p and the other one is 7p. Of these two, the smallest variable is 7p, right?
Yes.
Then
Yes.
the second one is you have to cancel out. Please don't forget that always every term is having a positive sign with that. Okay? So I'm taking the inverse operation, which is a negative sign. So negative 7p on both these sides. Please do remember, when you write, you can cancel out maybe later, but first thing is you have to balance it. Otherwise, there are high chances of forgetting. So you have to balance it. So immediately you write on both the sides.